Hi friends, welcome to this special lecture on the fascinating journey of data evolution, culminating in the age of big data and artificial intelligence. In this lecture, we'll be traveling through the decades examining key milestones that have shaped our current landscape. So we begin with the 1950s, where that was a time when data processing was in its infancy. This era saw the birth of mainframe computers, massive machines that occupied entire rooms and required specialized environments. These early computers, for example the UNIVAC, were primarily used for basic calculations and data storage, setting the foundation for the data-centric world we live in today. The 1960s marked the emergence of more advanced computers. This period saw the development of programming languages such as COBOL and Fortran, which enabled more complex data processing tasks. So, to this end, computers started to become more accessible, though still far from the personal devices you use today. The ability to process larger volumes of data began to grow, and along with it, the potential for more sophisticated data applications. The 1970s was a transformative decade with the rise of relational databases. Edgar F. Coates' relational model revolutionized how data was stored, accessed, and managed. At that time, big companies pioneered relational database management systems, also known as RDBMSs, thus making it easier to organize and retrieve data using the structured query language, also known as SQL. So the technological advancements in this era laid the groundwork for modern data management practices. Then we move to the 1980s. In this decade, the advent of personal computers and the client-server computing model brought data processing into homes and small businesses. Companies like Apple and Microsoft played pivotal roles in making computing more personal and widespread. This period also saw the development of local area networks, known as LANs, which facilitated better data sharing and processing across multiple machines, thus enhancing productivity and collaboration. The 1990s ushered in the Internet revolution, fundamentally transforming data accessibility and exchange. Among others, the World Wide Web, alongside advancements in networking technology, enabled global connectivity. This era saw an explosion of data generation as individuals and businesses went online, leading to unprecedented levels of information sharing and the birth of e-commerce. The 2000s were defined by the emergence of big data. So the volume, velocity, and variety of data began to exceed the capabilities of traditional database systems. Technologies like Hadoop and NoSQL databases were developed to handle these large-scale data challenges. To this end, organizations started leveraging massive datasets to gain insights and make data-driven decisions, paving the way for the data-centric business models we see today. The 2010s brought significant advancements in big data analytics and cloud computing. The ability to store and process vast amounts of data in the cloud made data analytics more scalable and cost-effective. Among other, tools like Apache Spark and machine learning frameworks enabled more sophisticated data analysis, transforming raw data into actionable insights. This era also saw the democratization of data analytics, making powerful tools accessible to a broader audience. Finally, we arrive in the 2020s, an era dominated by artificial intelligence and machine learning. These technologies are revolutionizing how we interact with and interpret data. AI and machine learning algorithms can now process and analyze vast datasets at unprecedented speeds, thus uncovering patterns and insights that were previously unimaginable. So the integration of AI into various domains such as healthcare, finance, autonomous vehicles, and many others has indeed opened new frontiers for innovation and efficiency. Thank you for joining me on this journey through the evolution of data. The key takeaway of this lecture is that indeed each decade has contributed to the sophisticated data ecosystems we navigate today. And as we look to the future, the potential for further advancements in AI and data analytics is boundless.